One of the most versatile programming languages right now is JavaScript. Node.js, React.js, Next.js. You want to learn any of this? You obviously need to know JS, JavaScript. In fact, you can build end-to-end really complex applications using JavaScript. You can do both front-end as well as back-end. In fact, the next course that is coming up on EduCourses, we are doing hands-on high-level system design, which I call HHLD. We'll be building projects like WhatsApp, YouTube, Zerodha using JavaScript. So yes, this video is a prerequisite for those who have enrolled for the HHLD course. But if you know basics of JavaScript, then also it is okay. This is a very, very beginner-friendly video on JavaScript. If you have no idea about what is JavaScript, this video is for you. We'll be starting from absolute basics, but by the end of the video, we'll be covering topics that confuse a lot of experienced software engineers as well. So without wasting any time, let's get started. You must have heard that there are three main components in web dev. HTML, which is the skeleton of all the web pages, CSS for beautification, and JS is the brain of web dev. So basically all the interactivity functionality that you see is all because of JS. But do you know the original purpose for which JS was developed? It was actually developed for execution within web browsers. So JS code is executed by something called JS engine, and every browser has its own JS engine to execute JS code. So Google Chrome has V8, Firefox has SpiderMonkey, Microsoft Edge has Chakra, and Safari has JavaScript code. And now it's time to write our very first JavaScript code and execute it within the browser itself. So as you can see, I've opened Google Chrome. Simple, you can open any site. I've opened google.com. Right click, go to inspect. Here you can see a lot of tabs, right? Go to console. And here you can actually do anything. Like for example, I do 893 plus 675. You can see the answer. I can do 780 into 340. You can do like this also. So this is actually executing simple JavaScript code. Here if you see, I can write console.log and I can log anything. Suppose I log hello. Okay, and here you can see I've logged hello. So like this, I'm actually executing JavaScript code within the browser. As I told you, Chrome is using the JS engine called V8. So does this mean that every time we have to run JavaScript code, we have to go to web browser, go to console and then run JavaScript code? Doesn't make sense, right? Yes, originally JS was developed to be executed within the browsers, but now we wanted to execute it outside. That is why NodeJS came into picture. What is NodeJS? It is simply a JavaScript runtime environment. Why was it developed? To basically run JS code outside the web browsers. And as you already know, to execute JS code, what do we need? A JS engine. So yes, Node.js is also built on top of a JS engine. Which JS engine does it use? Same as Google Chrome, which is the V8 engine. The V8 engine, which is used by Google Chrome also, it was developed by Google and it is written in C++. So that is why Node.js is also primarily written in C++. So in short, Node.js is just to run the JavaScript code outside. It is built on top of V8 engine and primarily written in C++. And now let's quickly see how it works. I'll be creating a separate tutorial on Node.js and I'll cover everything about how to install and how to set it up, everything. This is just to show you that we can run JS code outside using Node.js. Like for example, here I've created a simple JS file. Okay, and I can write any code over here. I can write console.log. Suppose I'm writing EduCourses. And how can I run it? Just I'm using VS Code. So I'm going to view terminal. Here in this, what am I going to do? I'm just going to do node and then JS tutorial.js. And if I run it, you can see I'm logging. And instead of just this string, I could have logged anything. So suppose I want to log 786 plus 905. So let's try to log that as well. You can see this will work. So this is how you can run the JS code outside the web browsers using Node.js. Okay, so now you must be thinking that Keerti, every time we have to run JS code, do we have to use Node because we do not know Node? No, that is not the case. To run JS, this is the easiest way. This is the last way that we'll be discussing and we'll be using the same way. In the starting, I told you that HTML is the body and JS is the brain, right? So that's what I'm doing. I'm creating an HTML file, JS tutorial.html. And in this, I'm going to add boilerplate code. How can I do that? Using the shortcut exclamation tab. I have the boilerplate code now. Simple code, okay? In this, in the body, I am adding a simple header, learn JS with Keerti. And after adding all the elements in the body, in the end of the body, it is suggested to add a tag called script. Now why in the end? Let all the elements load properly, because your script, your JavaScript code might take a lot of time. So that is why it is better that all the elements of your HTML, everything that you are adding, add that first, and in the end add script tag, and in the source you can add what JS file you want to add as the source. So I'm adding jstutorial.js as the script now. So this is done. Now how to run this HTML file, right? You can use the simple extension, it is commonly used. So on the right click, you can see open with live server. What is live server? So if you go to extensions in VS Code, you type live server. Here you can install it. There will be a simple button of install. I've already installed it. Just install it, and after that you will get this option that open with live server. And as soon as I do that, you can see this has opened, right? So this is the HTML code. Now when you inspect it, just go over here in the console. Now let's do this. Here you can see 1691 because that was what we had last printed, right? So suppose I print over here, hello. So here you will be able to see hello, right? Very easy. Now this is what we'll be doing. Let's finally start learning JS. As you can see, I've split the screen and this is going to be very interesting. Whenever we learn any language, we have to first start with variables because variables represent everything, right? So let's quickly see what are the different types of variables that are there in JavaScript. As I'll be writing the code in this JS file, you will be able to see the changes over here. So suppose, for example, I do let x equal to educursors. And as we had seen earlier as well, I can log. So I can log x as well. And another thing that I can log is basically the type of x. So here let's see what is the type of this variable x. So here as soon as I save it, you can see educursors and string. So the type of this is string. So these are the primitive types that we are discussing, primitive or value types. I'll be telling you that why these are called value types in detail. We'll be discussing this and it will be very interesting. So just hold on for a while. So these variables that we are discussing right now are called value types. So you saw one string, right? Similarly, let's see more. For example, I take y as some number. So suppose I take 1. Let me quickly change the variable names. Here you can see it is 1 and number. Similarly, I could have also given 1.5, 1.4, 1.5. It will still be a number. If you don't believe me yet, let me take another one and show it to you, so that you know that yeah, it is getting reflected. So suppose here I am taking integer and here I am taking a float variable. Like in C++, Java, you must have heard decimals, floats are separate, right? Versus in JavaScript, whether it is integer, whether it is decimal, it doesn't matter. The type is going to be number only. So one type that we saw was a string. Another type that we saw was number. And yet another type that is very common is basically if I put true or false. So if I put true and then I log p and type of p, let's see. So here you can see it is Boolean. So this is another primitive type which is Boolean. So what I have been doing so far is that while declaring itself, I am putting some value. What if I do not put some value? Suppose I just put let suppose w. And then I do console.log type of w. What do you think should be the answer? If I log the type and don't assign anything. So you can see there is an undefined. So this is what happens in JavaScript, that when you declare something but you do not assign a value to it, by default, the default value is undefined. As soon as I put any value inside this, suppose I put OPP, here you can see it has changed, right? Suppose I change Keerti. Here you can see it has changed, right? So suppose I initially don't do it and I log it. Now here itself I can change it also. Suppose now I change it to Keerti and I log it again. What do you think is going to be? So initially, as you can see, it was undefined. Once I assigned the value to Keerti, it saw that okay, the type is string, so it changed its type to string. If I would have put it to say 9, then you can see that it has changed to number. Also, one more thing, if you go to sources, you can actually debug the whole thing. Suppose I come over here, I can attach the breakpoints and I can do the same thing. So suppose I am just refreshing right now. Here you can see I can go to next line. I can go to next line and you can see the values over here. P, W, X, Y, right? So W right now is undefined. Suppose I come over here. Now when I come to the next line, now W value is assigned to 9, correct? So that is why you can see as I go ahead, it will keep logging. So till now things have been fairly simple, right? Things are going to be simple, but slowly we will get to the complex topics. I want you to really understand JavaScript and stay till the end of the video. It will really mean a lot to me. I've put in a lot of effort. So please stay till the end of the video. Make sure that you really learn JavaScript today. And please, a lot of you have not subscribed. It would mean so much to me if you could just hit the subscribe icon and the notification bell icon. It would really mean a lot to me. Please do hit that button. Okay, coming to this, so what we have learned so far, what are the primitive types? String, number, boolean, undefined, right? So undefined is also a type, by the way, as we saw. Now, can we assign a value to undefined? Like for example, here x was a string. Now, can I do x equal to undefined? See, technically we can. So if I log this value, you will be able to see that there is an undefined over here. Okay, so this works properly. There is no error, but it is advised to not do this. What is undefined? It is the default value. We are not supposed to assign any value to undefined. It will not throw an error, but it is not a good practice. Please do not do this. So now you're thinking, what if I want to, have something like key? I want the value to be empty. I don't want anything. How can I do that? Suppose the value was educourses. Now I want it to be empty. So there's another type for that. I can actually keep it null. So if you see for null, the type change to object. We will talk about this. Why is that? But the key point over here is that the default value of any variable, if you don't put any value to it, is going to be undefined by default. You're not supposed to put the undefined value into a variable. If you want to intentionally tell the absence of value in a particular variable, assign it to null. Okay? So these are the value types that we have discussed so far. I've written down them in one place. There's also symbol that came later. We'll not be discussing this right now. We'll discuss that later. Right now, these are the 5 types that you need to know. Also, one very interesting thing to note over here. Earlier, the type of this x variable was string. Later, I changed it to null. I also showed that I can change it to undefined. I can actually change the type of the variable on the fly, right? Here you can see educourses was a string. Later, I changed it to number. Right? If I just log it, it is essentially the same variable, but I am changing the type of the variable. That is why JavaScript is what? It is a dynamic language. You must have heard of this. Usually in other languages like C++, Java, Go, C#, you must have heard those are static languages. What does that mean? Suppose over there you do int x equal to 2. Now you can change the value. You can put from x equal to 2, you can do x equal to 4, x equal to 6. But you cannot change the type of the variable. Like from integer, you cannot change it to string. Once you have defined the type, you cannot change the type. You can only change the value. So that happens in static languages like C++, Java, Go, C#. Versus in dynamic languages like JavaScript, Python, PHP, what happens? You can change both the value and the type as well. Like over here, you can see here x was earlier string. It was educourses. Later, I changed it to 8. Right? Or I am changing it to 5 because 5th April is when HHLD course is starting. So if I change it to 5, so basically the type has now changed to number. So the same variable, I am able to change the type as well as the value. That is why it is a dynamic language. So congratulations, we have seen the primitive or value types. We are leveling up a bit, not much. We are going to see reference types. As you can see, I've already written, there are 3 types, objects, arrays and functions. Let's quickly look at them one by one. What are objects and why do we need them? For example, a very common example. You're talking about a student. Now a student has name, age, height, weight, so many things. A person, an employee. Now employee has so many things, right? You cannot keep accessing those things separately. Like suppose for a student, if I have 5 things like name, age, height, weight, I don't want to access them separately again and again per variable. I just want to, whenever I say student, I should be able to get all the details of students together. So basically, I want to group all the properties together. So that is what an object does. Here it is very simple. Okay, I'm just creating a course object. Very simple. All it is a collection of key value pairs. So for example, I can just put any key value pair. Like for example, I want to put HHLD title. Okay, and then I can put description. I can put it as projects. So it is going to have a lot of projects and I can put suppose rating. I can put it like 5, just putting. Now here note that the types can be different. Here there are strings and here there is a number. you can have different types basically grouped together, and you can also log it. So basically if I want console.log, I can log the entire course also. And what do you think is going to be the type of the course? So suppose I log type of course. What do you think will be the type now? Let's see. So here you can see I actually logged the entire course. Here you can see title, description, projects, and the type is object. So now you must be thinking that Keerti, you're accessing the entire course. What if I want to access just the title? How am I going to do that? Very simple. So there are two notations for that. One is called dot notation. You can just do dot and you will be able to see that, okay, this is this. Another notation is bracket. So I can just go like this, and in double quotes or single quotes, I can write title. So like this, you will be able to see. Similarly, I could have written description also. You will be able to see. So there are two ways. So one is called dot notation, another is called bracket notation. I've been telling you that I will explain to you why are value types called value types and why are reference types called reference types. It's time to finally get to that, and it is going to be very interesting. You are going to absolutely love it. Let's look at it. So what I'm going to do is I'm going to take two variables and I'm putting a random string to it like Keerti, and I'm going to take another variable and put x into y. Okay, so y equal to x. Now what I'm going to do is change only the value of x. So I'm suppose making it educourses. Now tell me this, what according to you when I log, okay, when I log, what do you think will be the value of x and what do you think will be the value of y? Do you think the value of y will also change or will it not change? So this is interesting point, right? Do you think the value of y should change? So x is educourses, we know that. And let's print y now. So as you can see, y did not change. So y remained Keerti. Why? Because when we put the value of x into y, the value got copied. What was the value of x? It was Keerti. So y remained Keerti. Only x changed. So this what happened? It was copied by value. That is why it's called value type. Versus, just look at this, very interesting. Suppose I take another two variables. But now instead of just string, I create an object. Okay, and inside this, suppose I take Keerti. So I'm copying P into Q. And now again, I'm going to change the value, okay? But this is how I am changing. So I am changing this to educourses. Now same thing when I'm going to log. What do you think should be the output? This is very interesting, right? Here when you printed, both of them printed educourses. Both of them logged to educourses. Why? The Q value also changed. Because this copied what? This copied the reference, not the value. So the reference of P was copied into the Q. So when you changed P ka name, Q ka name also got changed. This is copy by reference. And this is going to be true for all the reference type. Similarly, all the value types are going to be copied by value. So I hope now you're not going to forget it why are value types called value types and why are reference types called reference types. The best part about learning JS is you can just literally while browsing through, you can just open console and you can try this out. You can write the code there itself in the console itself. And you should try this with all the value types for all the reference types. And now let's understand arrays and functions. But I hope you found this very interesting. And please do follow till the end. Do not leave the video in between. I hope you have subscribed and please do comment that till where you watched the video, how much did you practice? Let's understand arrays now. Coming to arrays, here also we put some values together. But here instead of key value pairs, what are we doing? Here we are just putting in a list and we can access them using numeric indices. It is very common. You must have seen it in other languages as well. But it is slightly different than other languages. Let me tell you how. So here I am just creating an array. I am creating courses. So here you can see HLD, LLD, DSA. These are the courses that I've already taken. So I have put them in an array, right? Now I can also log them. So suppose I log courses. Now I can access them by numeric indices and the index starts from 0. So it is 0, 1, 2. So if I log suppose courses of 0, you will be able to see HLD, right? Similarly, I can log courses of 1, courses of 2, right? HLD, LLD, DSA. But now how it is different than other languages is that in C++, Java, usually you will see the type has to be same. But here, both length and the type can be dynamic. Like for example, here in this, I can keep adding, like for example, I add 6, which is a number. I add suppose Boolean. I can also add null and I can access it also. Like suppose I access 3. So you can see that the value is going to keep changing. So here you can see 6 true null. Right, so I can actually put different values over here. And another very interesting thing is that if I try to log type of courses, what do you think will be the type? So interestingly, the type is object. So this is very interesting point, guys. So arrays are actually objects. And after this, we will see that when we try to log type of function, that will also be object. So actually arrays and functions are objects only. So if you think about it, the only reference type is actually object. Okay, interesting, right? And you can also, by the way, log the entire courses and see, you'll be able to see the entire array like this. And now we are finally starting with the most important part of JavaScript, which is functions. This is going to be there in almost every topic that we discuss after this function is. I cannot tell you how important. Coming to why do we need functions, like objects and arrays, we just put values together. Functions in very simple terms, whenever you have to do some task again and again, you can create a function. Like for example, I can do this in very simple way. Suppose I have to keep creating the courses, okay, and different courses, and I have to do the same thing again and again. So inside this, suppose I just pass the course name and I have to basically keep creating that again and again, right? So right now I'm just logging it. But I am logging, like for example, creating and then course name. So if I do this, now I can keep calling this for different courses. Like for example, I do this and I pass HLD, I pass LLD, and here as soon as I save it, you can see creating HLD, creating LLD. So like this, I can keep creating courses, I can keep calling the function again and again. It is finally time to level up, and to set some context, let me show you something very interesting. So here we declare this function and we are calling it, right? Now tell me something, if I move this particular line above the function, should it work or not? Well, in most of the languages it should not work, but here you can see that it is logging creating HLD. Similarly, if I suppose just change this to DSA, you can see it changed to DSA. Why is this happening? Again, let me show you one more example. Suppose I do var x equal to 10 and I do over here. Okay, I am able to access the variable even before declaring it. I mean, x has been declared later. How am I able to access it earlier? Even though the value is not there, but I'm able to access it. How? Is it the same x? I mean, what if I log it over here? Let's see. So later it is logging 10, but initially it is logging undefined. What is exactly happening? For this, we need to understand how exactly JavaScript code is executed. Now it is time to really understand very interesting concepts. Listen to me very carefully. These 2 minutes are the most important minutes of the entire video. We are going to understand the most important concepts, and you will be able to understand a lot of very complex concepts because of these 2 minutes. So listen to me very carefully. You need to understand how JavaScript works. So for that, first thing, let me tell you that the environment where your code is evaluated, executed, basically the variables, the functions, the scope, basically what can you access from where, the entire environment, there's a term given to it which is called execution context. JavaScript people love giving fancy names. Execution context, you are going to hear this term a lot. It is nothing but the environment constituting your variables, functions, scope chain, everything. Execution context. So now what happens, every time you run or execute a JavaScript code, there is an execution context created. So initially there is a global execution context created, which people also call GEC, global execution context. And now every time you create a new function is called, a new execution context will be created and will be added to the call stack. So there is one global execution context, and then there will be execution context added to the call stack every time you call a function. Don't worry, we will actually see this execution context being created. We will see what all is there in this execution context. So everything will be completely clear. Just listen to me for now. Now this execution context also has two main components or phases. Okay, in very simple terms. The first component is actually before running the code. So when you see the JavaScript code, before running the code, first phase happens. Now what happens in the first phase is that some memory is allocated to the variables and the functions. Just memory is allocated. That is why this phase is called memory phase. And in the second phase, the code is executed line by line, one by one. So JavaScript is a synchronous single-threaded language. It is synchronous. So one by one, in a single thread, it starts executing the entire code. That is why this second phase is called the code phase. Okay. Again repeating, very simple. Execution context is the environment of everything. Now there are two phases in which your code is executed. Okay, first phase is basically the memory phase where only memory is allocated for your variables functions. In the second phase, the code is executed. Now let us see how things are actually happening. So what did I tell you? There is one execution context and it has two phases, right? What are the two phases? First phase is the memory phase when memory is allocated. Now this, because memory is allocated to the variables, it is also called variable environment. And the second phase is the code phase because code is run line by line in single threaded manner, synchronous single threaded language. Okay, so this is called code phase or thread of execution. And let's actually see something awesome. You will actually see this and you will be mind blown. Before the first line is executed, I am putting up a breakpoint over here. Okay, and I'm refreshing this. As I refresh, here you can see a global object, right? There is one global object over here. And here there are a lot of things. Now these are set in basically alphabetical order as you can see. So you will see from C, okay, let's start from C. Here you can see a function called create course. And you can see that, okay, the name is create course, what is the length, arguments, a bunch of things. Similarly, if I go down, instead of putting so much effort, I am just going to rename this by A just to make our life easy for now. And now once I refresh it, you can see there is one A variable which is undefined. And this is before the execution of the first line itself. Why is this happening? Because of the memory phase. Now memory phase is over. We are going to start executing the code. We are getting into the code phase. That is why A is also there, but it is undefined. Now this line is not called yet. We have not started the code phase. So that is why the value is undefined. This we had seen earlier also, right? Similarly, if we see the function create course, it is there. But now when I start running it line by line, let's see what is going to happen. So here in the log, I am in the 13 line right now. After this line was executed. So here you should be able to see in the console that, okay, it was undefined. Okay. Now in this, when I do create course LLD, we will go inside that and now you'll be able to see create course. So here you saw 10 came in this line and LLD came in this line. So now I hope you have understood in detail that because of the memory phase, what happens? This is very, very interesting, right? Let me show it to you once more because this is extremely important for you to understand. So the breakpoint is over here. I'm refreshing it. Here in the global, you can see A is undefined. There is nothing on the console. When I go line by line to the next line, okay, let's put a breakpoint over here, everywhere, so that you can actually see things happening. Here you can see creating DSA, okay, so the function was called. After this, when I logged A, it was undefined. Now I am going to run which line? 19 line. Now here A value was changed to 10. It was undefined, now it changed to 10. After this, when I run it, you will be able to see log as 10. After this, creating LLD. So line by line. So I hope now it should be completely clear. This is extremely interesting, right? Why is this happening? Because of the memory phase. Before we start running the code, before we get into the code phase, memory is allocated for the variables and the functions. And this concept of being able to access or extract variables and functions before initializing them, before putting a value into them, is called hoisting. Again, guys, the name is fancy, but the concept is very, very easy. Once you understand it, how the code runs, this becomes very easy. What is hoisting? Just that you are able to access the variables and functions before actually initializing them or putting any value into this. This is called hoisting. Notice one more thing over here. So there is something called window. So basically every time your code is run, there is a global object created. In Chrome browser it is called window. In Node.js it will be called something else. Now let me actually show it to you. So when I do var suppose a equal to 10 and suppose I do console.log a over here. And when I do console.log a over here. Now this is simple, right? It will be undefined before and 10 later. This much we have understood, right? And we can try running it also. So undefined and then after that 10, correct? What I can also do is basically log this dot a, which is a keyword, which is essentially referring to this global object. That is it. So when you say a, this implicitly means this dot a. Or you could actually also say window dot a. So this and window is the same thing. It is referring to that global object. If I refresh it, you will be able to see it over here. I am removing the breakpoints. Here you can see it is undefined 10, 10, 10, right? And here you can see clearly. Similarly, if I just put this entire thing before, here you will be able to see undefined, 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 10, 10, 10, right? So all of this is undefined. You can also actually log this window and see. So if I log the window, you will be able to see this. Here you can see I have logged the window and inside this there is there will be the function if I would have created it and so many other things, right? So this global object is created whenever you start executing your JavaScript code. You can also see to be sure that this and window is the same thing. You can actually log this equal to window and this will actually return true. So as you can see, so they are the same thing. Now that you have understood these concepts in very easy way, tell me something, okay, and be honest in the comments. Did you notice that initially when we were declaring variables, I was using let x equal to something, let y equal to something. Suddenly, when I started explaining execution context, hoisting and all of this, I started using var. Did you notice this or not? So, am I trying to make things more complex for you? No. There was a reason why I did this. Let me know in the comments, by the way. I want to know how many of you have attention to detail. So if I change this to let, okay, and I actually run this, I get reference error, cannot access a before initialization. But this is going to work for var. Now why? So this is very interesting. Let's now understand this. So there are three ways to actually declare variables. One is const. So there is one more way, const. Then there is let and then there is var. Let me summarize it to you in literally one line. Wherever you want constant value, basically if I want const over here, see this is also going to throw error by the way. So const and let are more strict than var in very simple terms. Const and let are more strict than var. Okay, they don't let you access them before. We will discuss it, don't worry. So suppose I remove this. In const what happens as the name suggests, suppose I try to change the value again. Okay, so you can see assignment to constant variable is the error that I'm getting. From the error itself you will be able to understand, right? Assignment to constant variable. So yes, the summary is that whenever you want that your variable cannot be changed, the value cannot be changed, use const. If you want that the value can be changed, if you want to allow that, use let. Avoid using var at all. And I will explain it to you why, but this is the summary. Const and let are more strict than var. Use const whenever you want your value to be constant. Wherever you want that it cannot be changed, use const. As you can see, we'll start getting this error. Use let, otherwise avoid using var. This is the general guideline. And now let's understand this in detail, how things are happening. What we are going to do is take another variable, which will be const. And suppose I'm taking that as 20. I'm removing all of this. So I'm taking one let, one const and one var. Okay. And let's put a breakpoint in the starting of the code over here. And let's see what is happening. Now I refreshed. Here you can see that this C is there in global. This C variable, we had used var for this, okay? So it is initialized with undefined. So memory is allocated to it and it is undefined. But the interesting part is that A and B, these two, are not there in global. They are in some other space. Here you can see inside script, right? A and B. And the value is unavailable. So that is the difference between let, const and var. Before the code phase is starting, before we are starting execution of the code, we assigned memory for variable C because it was with var and it was initialized with undefined. But as I said, let and const are more strict. See, they are also hoisted. There is memory allocated for them. But they are not initialized with undefined. The value is unavailable. So this time or this period between when you created let or const and when you initialized it, there is a term for that also, as we all like making so many terms. This is called temporal dead zone. So yes, it can be confusing, but it's fine. You are understanding it. Relax, stay with me. Hoisting was what? That there is memory allocated before initializing it and you can actually access it. But you can access what? You can access var. You cannot access let or const because there is a temporal dead zone or there is a period where you will get reference error. So basically if I try to do console.log over here, for A and B I am going to get error. So if I try running it, see I got reference error because temporal dead zone. Similarly, if I suppose try to log B, I am going to get error. Here you can see cannot access B before initialization, but it is going to work for C. So if I remove the breakpoint, you will be able to see undefined. In short, just remember, if you get confused, just put up a breakpoint in the starting. Okay, I'm just removing this. Remember this concept and everything else will be clear. So if you see over here, A and B are in separate space. They are not in global versus C is in global. So if you declare your variable using const or lent, it is not going to be in global and you cannot access it before initializing it. This is JavaScript's way of making sure that everything is predictable. You're not accessing the variables before initializing them. That is why it is always suggested what? Again, quick revision. Use const if you do not want your values to change. Otherwise, use let, avoid using var. That is why it is also, you must have seen, it is usually suggested that declare your variables at the top of the code so that you avoid getting into all of these errors. You avoid temporal dead zones. One last thing that you need to understand for this concept is that const and let are basically block scoped. I will explain you what that means. So const and let are block scoped and var is considered function scoped. So now let me explain. Firstly, what is a block? So basically, wherever you put two curly braces, this is a block. Simple. So even in a function, what do you put? You put curly braces. Even in if else, any block, you put curly braces like this, right? So that is also a block. So I can also write code like this. So now this is within a block. So now if I try to log this, I will not be able to access A and B versus I will be able to access C. So let's try that. So I save this and I try running this over here. So I'm in this line, let's execute it and see, and I will get reference error, A is not defined because the scope of A is within this block. Similarly for B also, I will not be able to access it. As soon as I run it, you will be able to see reference error. But if I log C, I will be able to access it. So here you can see I was able to log 30. But within this block, I will be able to log all A, B and C. So outside the block, I can only log C, but within the block, because const and let are block scoped, I can access them only within the block, not outside. Simple stuff, right? This is very simple, basic stuff. Nothing very complex over here is happening. So here you can see I was able to print all of them. Since we are talking about scopes, let's also see what happens in functions. So I'm going to try writing a simple function. I'm going to call it hello, simple any random function. And inside this, I'm going to take a variable and I'm going to try logging the variable. So when I call the function outside, let's first see that what happens to the scope when the function is called. So for that, I am adding the breakpoint. So here we will see before adding the function, what happens while the function is running, what is happening to the scope. Okay, so let's start from the starting. Right now, there is only one global object. If I go inside this global and I scroll down to edge, here you will be able to see this function hello. So this is there. Now I'm going to call the function hello. Okay, so we are now going to run the 23 line. So I go inside the function, and as soon as that happens, see there is one local context that is created. Earlier there was just global. Now local is created, and inside this there is one x. Now x is there, but the value is unavailable because the line number 19 has still not run. So now you're understanding, right? And there's also this, there's also window that is there inside local as well. Now if I go to the next line, now you'll be able to see that x ka value has now changed to 10. Now when I go to the next line, we have logged 10. Okay, so return value is not there, it is undefined. And when I come out, local is gone. So the function has run, it is gone. So there's a context that is created when you call the function, and when you're done with it, it is deleted, right? Now let's see one more important point. So here there was let x equal to 10. What if I tried to create yet another variable over here, let x equal to 100. What do you think would be the output? Let's try running this. Let's see line by line what is happening. So currently I am at this line. Here x is there in a separate space, not in global, because it is let, correct? Now I come over here, I call the function, so local is created, x is still not there, it is unavailable. Now x value becomes 10 because I am in this line now. I am going to now log 10. Why? Because what is it referring to? It is referring to this scope within the function. Correct? That is why it printed 10, not 100. Versus, I am just removing the breakpoints now. If I removed this, okay, and if I ran this, what is going to happen? You can see now the output is 100. So basically in very simple terms, what happens is that when we are inside a function, we will see, is this variable inside this function or not? Is it available in this scope or not? If it is available, it is going to take precedence, even if it is same variable name is available outside. So when there was let x equal to 10, it will consider this 10 only, even if it is outside. It is not even checking outside. But if this is not there, if it is not there in the scope, it is going to go to the outer scope. What is the outer scope over here? There is basically global, right? So it checks, oh, there is an x over there. Then it is going to access what? It is going to access this x. So it first checks its local scope. Then it goes outside and checks. And this, again, another fancy word, is called lexical scope. You basically check where is it located and can we access it or not. Here it is going to see, is x present in this scope? No, then it is going to go outside and see. This is called lexical scope. Very simple. And quickly making one more thing clear. See, here we could access the variable from global to local. But it is not going to happen vice versa. Like for example, suppose this was inside and I was trying to log it outside. Is it going to happen or not? No, right? This should make sense. This is very basic stuff. Because it is inside this, I should not be able to access it outside. So in local, I will be able to access the outside one. But obviously from outside, I cannot access the inner one. So I hope this is clear. This is a very, very important point. Here it is not defined, it is going to say, because the scope is within this function. It's finally the time to deep dive into functions. Functions are so important in JavaScript that they're in fact called first class citizens. Yes, you heard that right, first class citizens. And when I tell you why they are called first class citizens, and if you're coming from like a different language, you might find it a bit weird in the starting. Let me tell you the reason. So functions in JavaScript can actually be assigned to variables. They can also be passed as arguments to different functions. They can also be returned from functions. They can even be stored in data structures. Very interesting, right? Very cool also. Let's actually try writing the code. We will see all of this happening in code, so don't worry. Functions are called first class citizens in JavaScript. So firstly, I'm beginning with like a simple function. We have already seen these so far. So I'm going to pass a and b and return a plus b. So this is a normal add function. As we had already seen, we can log the function itself and we can also log what? The result from the function. So we are returning a plus b, right? So we can pass 2, 3 and we can actually log the answer. So here you can see the first statement. This one is going to actually log the function. The second statement is logging the answer, the resultant. Now what I could actually do is take this function, but instead of having a name to the function, what I'm going to do is assign it to a variable. So you can see over here, I'm going to do let sum equal to this function. And similar to this, I can actually log this variable, and I can also do sum of 2, 3. And as soon as I save it, you can actually see that the output is same, the log is same. But it is very different on how it works. And you will be able to understand because your basics are now clear. So actually, let's see. It's going to be very, very interesting. This is the first line that's going to be run. So I'm putting a breakpoint over here. I am putting a breakpoint everywhere. And let's see, okay? I'm going to try running it. Here, as soon as I come, okay, so this is the first line that's going to get executed. You can see that there is a sum variable that is available in the script section. Why? Because now sum is what? It is a variable. You remember it is let. If it was var, you would see it in global. But because it is let, it is not in global. It is somewhere outside. But the interesting point over here is that the memory is allocated for the variable, not for the function. Versus in this case, what is happening is there is memory allocated for the function. So you see the difference. Although both this and this essentially mean the same thing, but how it's working is completely different. So before I am over here, you can see that memory is allocated for function in case of this, right? You can see this add function. You can see name is add, length is 2 and all of this. Versus there is memory allocated for a variable in this case and not for the function, right? And it is like this, right? And if it was var, just in case if it was var, and if I execute it, here you will be able to see this sum. Here now you will see that script is gone. Now we will find somewhere, we will find it in global itself. So let's find it. Now you can see over here sum is undefined. Why? Because it was a variable. Why? Because I declared it using var. Now I'm going back to let. So these small things are very, very important for understanding. Now I'm going to refresh it again. Here you can see I am back to this. Now let's go to the next statement. Now here what am I logging? Add of 2, 3. So that is the function. Then I've logged this. Now when I go inside the function, okay, as whenever I'm going to go inside the function, you will be able to see that there is a local created. And in this local, note very, very important thing, there are two variables, 2 and 3, right? And within this local, there is one very, very interesting thing. There is this window with a lot of things inside it. So it doesn't just have A and B, but it also has reference to the outside window. Get my point? Now this is very interesting, right? And we are going to talk about this more in detail. But for now, what did you see? That we can assign function into a variable. Now let's see how functions can be passed into another function, okay? So I'm going to be using this right now. I'm going to be using this function, okay, when we are assigning it to a variable. Now, suppose there was sum, okay? Now I want to create another function like this, which I'm going to call diff. So there was one sum. Now I am calling diff, and I'm going to return a minus b. And now I have yet another function. You can also log it and see. I'm removing the log statements for now. What I'm going to do now is write yet another function, and I'm going to call it operate. And in this function, you can actually pass which operation you want to do, and you can pass the function inside this and the variables a, b. So what I'm going to do essentially in this function is call this operation function for this a, b. And whatever this operation function is going to return, from this operate, I can just return that. So what I'm going to do is I'm going to call the operate function. And what all things am I supposed to pass? The operation function. So I am passing sum, and I am passing 2, 3. Similarly, I can again call it. And now this time, what function am I going to pass? Diff 2, 3. Let's try running it and see. Okay, I have not logged it, so I'm going to log it as well. Okay, so this worked. This is so cool, right? So basically what I'm doing is in this operate, I am passing that what function I want to call. And from here, I am calling this function. So here I am passing the function as an argument. So what all things we have seen so far? I can assign function into a variable. I can also pass it as an argument. And I just want to make sure that you don't have any confusion. So just making sure that instead of assigning to the variable, if you would have just written function sum and function diff, like the normal way in which we were doing earlier, If you did this also, then also this would work. You can see it is 5 and minus 1. Now time for another fancy term. So I'm just writing these things down so that you know that what all fancy terms we have learned so far. We'll also do quick revisions, so don't worry at all. So I told you that all functions in JavaScript are called first class citizens. And there's one more fancy word which is very famous in JavaScript. You will keep hearing higher order functions. Now you will say, Keerti, what is this? Why so many concepts? You know what? Higher order functions are nothing but regular simple functions that either take functions as arguments or return functions. That's it. Saying that again. So higher order functions are basically regular functions that take functions either as arguments or they return functions. So in this case, this operate is taking a function as an argument. So this is a higher order function. We will also see examples of functions being returned from functions. We'll see that, don't worry. But I hope all the terms are completely clear. Just fancy terms for very simple concepts. Just remember that functions are first class citizens. They can be assigned to variables. They can be passed into functions. They can be returned from functions. And what are higher order functions? Regular functions in which you either pass functions as arguments or you return the functions. Simple. Before we get to more complex topics, let me tell you something very interesting. So from ES6, they have come a lot of fancy ways of writing functions. I have to show it to you so that when you see them, you don't get overwhelmed. These are just different ways of writing the functions. If you are finding it overwhelming, it's okay. Just know that functions can be written in different ways. Some people find these ways simpler to understand, simpler to read, and you get used to them also. You might find it ki why so much, why so many terms, but it's fine. You're learning JavaScript for the first time. Stay with me. We are just beginning with the complex topics now. If you have watched till here, you need to watch till the end. Now we are doing some really interesting things. Please do not leave the video in between. You have come so far. I would love it if you could stay till the end and understand all the concepts. So how till now we have been writing function like this. I told you that you could also do let sum equal to, and you could just remove it from here, function this. Now you could actually from ES6 remove this function as well. And after this parameters, just add an arrow. So this will also work. Let's try running it. So I refreshed it. This is working. And if it is just one line, now function can be huge, right? If it is just one line, just one expression, you can actually forget about the return statement also. Just do a plus b. So this entire function can be written in one simple line as well. So now some people will find this very easy, but you need to understand it how things are happening. So these are basically the parameters. You can either put curly brackets and write your entire function over here like this. Or if you have an expression, you can actually just do a plus b. You don't even need to write a return statement. So this thing, if you have to convert this into one line, how you could write let diff equal to, and then the parameters a comma b, and arrow function, because it is just one line, one expression, I can just write a minus b. So this is essentially the same thing. I can run it as well. So this is another way of writing the code. You will see it a lot. Don't get overwhelmed. You know this, it's basics. It will be clear. So now you have seen functions being assigned into variables. You have also seen functions being passed as arguments. Let's also see functions being returned from under the functions, right? So let's try writing the code for that. It's going to be very interesting, guys. So I start writing function. Now I want one function to be returned from another function. So I'm basically writing one outer function. And from inside this, what I'm going to do is return another function. And I'm going to write it like this. So function inner. And I'm going to log something inside this. Suppose hello. Simple, right? Now this outer function is returning this inner function. I need to store it somewhere. So I'm going to take a variable and I'm going to actually call it, suppose, returned function stored in a variable. And from where is it going to return? When I call the outer function, from that I'm going to get a function in return, which is this inner function actually. So let's log it and see also, so that you are completely clear about what the hell I am talking about. Okay. So let's log this. And can I also call this function? Let's see. So let me put the breakpoints for us to be able to understand everything properly. I'm also putting it over here. I'm basically putting it everywhere. Let's run it. Okay. So this is the first line where our code is going to start getting executed. Here you can see, because this is a let variable, it is not in global. Okay. Now, next thing, I have called the outer function. So I'm returning inner from over here. Note that the inner function was not called. It was just returned. Okay. So now when I go to the next line, in this returned function variable, you can actually see the inner function. Right? This was not before. It is there. The inner function was not called. It was just returned as it is. Okay. And in this returned function, okay, in this inner function, notice something very amazing, very, very amazing. Go inside the scopes and see there is global. You can see everything over here. Okay, we are going to talk about this. I showed this to you earlier as well. Going to talk about this in detail. Now I am over here. So what I did was I logged the function. So here you can see I logged the function. It was not like I called the function, I just logged it. Now I am going to call it. And now the function got executed and hello was logged. Very interesting stuff, right? Now let's play with it a bit more. So I'm going to take another variable. Let a equal to suppose 10. And over here, instead of logging hello, I'm going to log a. So should happen nothing big change that I did, right? I'm just going to run it. Here you saw I logged 10. Now tell me something. Suppose I change the value over here, a equal to 100. What is going to be logged? Just think about it. Okay, I'm saving it. Now I'm going to run it again. Okay, so I'm again starting from over here. And when outer function is run, now a value now becomes 100. So now when you are going to return inner, in this script you can actually see a is 100, right? So inner is there. Now in this returned function, we can see inner is there. And in this, if you see script value is there, a equal to 100. So note here, this is very, very important and very, very interesting. See that a's value is over here, but is it actually a value? Okay, what is it? We can see a is 100. Even though we are outside, we have returned the inner function. It is not like the value is 10, the value is 100, whatever it was. Okay, now I'm going to get out, and when I call this, you will see the log is 100. Even now you might think like, what am I trying to say? Now let me make it even more interesting. So I returned the function variable over here. Now what I'm going to do is, after this, I'm going to change the a ka variable to 20. Now you will understand what I'm trying to say. Okay, now I've saved it. I am going to put breakpoints everywhere. And I'm going to try running it. So here, I am right now over here. Okay. You can see there is one local. Basically, I'm in this function right now. I'm inside the outer function, right? So when I'm inside this function, there is one local context. And inside this, there is inner. And inside this, there is scope. And the value of a is 10. Right? Because I have right now not executed a equal to 100. As soon as I execute a equal to 100, you can see that in this scope, a has now become 100. Okay? Okay, fine, cool. Keerti, now you are going to return inner. Okay, we have returned inner. So if I go to this returned function where is it going to be? It is going to be within the script, correct? Not in global, it is within the script. And if I see over here, I can see a ka value is 100. Right, a's value is 100. Now this is returned. But now outside when I change a equal to 20, you can see that a also got changed. Why? Because the reference to a is saved in this returned function var. So this is what I've been trying to show you. In this returned function variable, what is there? There is this inner function, but along with this inner function, there is also reference to a. So even though outside, like even though after saving it into the variable, you are changing the value of a, this a is actually changing. So now when I go ahead, 20 is printed. 20 is logged. Why 20 is logged? Because reference to a is there in this return function variable. And now, yes, it's time for yet another fancy term. We will revise all the fancy terms, don't worry. This function, along with what is the term? Lexical scope, is called closure. Why lexical scope? What is there in this lexical scope? It has reference to all the variables outside. So you can say in this returned function, it has scopes, right? It has reference to these variables. So even if outside you're going to change the value of a, it is going to change because it has reference to a. Very, very important point. Trust me, I know that you're overwhelmed right now. You're thinking JavaScript is hard, but it is not. Please stay with me. It is going to be easier. Let me explain this to you once more. So what I did was I returned a function. So this function was returned. Inside this function, there was something that I was logging, which was this a. So even though I changed a outside, when I log it, I saw that even this a is logging what? It is logging this new value. Why? Because in this return function variable, I have access to this function, firstly to this function, and also to its lexical scope. And in this lexical scope, this a is there. And I have reference to the a. I have reference to this a. And that is why when I'm logging it, it is going to change. So I can keep playing with it outside. I can do suppose a equal to 80. And let's try running it again. Now you will be able to see what? So here you can see as I come over here. Now a value is 80. When you log this, what is going to happen? You log first the function, you will see 80. Because I changed it outside, even then it is changing. Why? Because this is a reference. Even if it is not clear, it is fine. We are going to take so many examples, it is going to be clearer. And we are going to revise all the important terms as well, so don't worry. So what I'm going to do now is, I'm going to take a counter. So suppose let count equal to 0. And inside this function now what I'm doing is, I am going to do count plus plus, and I'm going to log this count. I'm removing this, and in this return, suppose I'm going to call it increment counter. Okay, and this increment counter, if I keep calling it again and again, what do you think is going to happen? Let's see. I'm just putting the breakpoints over here, and let's start running it one by one. So before this line is executed, you can see that increment counter is there. It is not there in global. Why? Because it is let. Now let's run it. So now I did count equal to 0, because here what are we doing? We are calling the outer function. So we have called the outer function. So right now we are in count equal to 0. Now we are over here. We are returning the inner function. We are not calling the inner function. So we just returned it. Now we are going to call it. Okay. So in this increment counter, you can see in this variable, there is the function. Here you can see there is scope. There is something called closure. Right. And in this closure, you can see that the count is 0. Okay. What is closure? It is just the function and with the lexical scope. So closure count is 0. Let's try running it. Now you can see that inside this the count is 1. Right? The closure is what? Outer. Let's try running it once more. So you can see I'm calling this again and again actually. If I put breakpoint inside this also. Now if you go over here, you will be able to see count equal to 2. Again, now you can see I have come inside this. I am also logging it at every point. Here you will be able to see now count is 3. You will see the log. Right? So why is it happening? Because of closure. Very, very important point. Function with its lexical scope is closure. So basically in very simple terms, this variable has this function. Along with it, it has these variables and it has reference to those variables. Those are changing as we are changing the values of that. Because there is reference, this is called closure. Okay, now imagine this. You keep creating a lot of closures. What is closure? Function with its lexical scope. So you basically keep references to all the variables outside and you keep creating functions like this. You keep returning like this. Now you can imagine there will be overconsumption of memory. There will be too much memory allocated to these references of variables and you will end up having what? You will end up having memory leaks. You will have to handle them. So that is why use closures only when absolutely needed. Don't just keep making a lot of closures because you might end up having memory leaks. Congratulations, give yourself a good pat on the back. You are officially ready to move to the topics. A lot of experienced folks also struggle with these topics, but you will be able to understand because you have understood the basics. But before doing that, let's quickly revise all the fancy terms that we have learned so far. So we started from understanding execution context, which is the environment where everything is happening. Now this has two phases. First phase is even before the code starts getting executed, which is the memory phase. Memory is allocated to variables, functions, which is also called the variable environment. Then comes the code phase where code is executed line by line. Remember in JavaScript, it is single threaded. Everything happens synchronously. Then because you understood the memory phase, you understood that you can actually access the variables and functions before initializing them. And that is called hoisting. Now all var, let, constant, everything is hoisted, but the difference is that var is initialized with undefined versus let and const are not. Var is in global scope, let and const are not. Now when you try to access these variables and functions before they are declared or initialized is called hoisting. You can hoist variables, you can access var, but when you try to access let or const, you're going to get a reference error because you're going to be in temporal dead zone. What is temporal dead zone? When you try to access let or const before actually initializing them, you are in temporal dead zone because they are not initialized with undefined, var is. So now you understand the reason behind the guideline that try using const because if you want your values to be constant, otherwise use let, avoid using var. Const and let are block scoped. What is lexical scope? It basically tells you what all you can access and it depends on what? On how your code is written. So basically you're first going to try to see is this variable present in my local? If it is not, you're going to go to outer function, then to the outer function, then to global. So this is nothing but lexical scope. Functions are called first class citizens. Why? Because you can assign them to variables, you can pass them as arguments, you can return them from arguments. In a regular function, if you are passing another function as argument or if you are returning a function, that is called higher order function. Like in this example, outer is a higher order function. Similarly, we saw one more, operate was also a higher order function because we were passing another function into it. Now this function with lexical scope is called closure. Like in this example we saw in this increment counter, we basically have this inner function plus we have reference to this count. So this function along with its lexical scope is called closure. One question that you should be having right now is that Keerti, you are again and again saying that okay, JavaScript is single threaded, everything happens synchronously, but isn't that very inefficient? Because isn't it a very common use case that we want to fetch some data, we want to get some data from another server, from another database, maybe I want to read some files. Now all of this takes time. We don't have it in our hands that how much time is another server going to take to give me the data. Plus it is on network, there might be some error. It is going to take a lot of time. Am I going to stop there and wait over there? Am I going to get blocked? Because it is synchronous and single threaded, right? No. So there are amazing ways in JavaScript to have this non-blocking behavior. This is called non-blocking behavior, or you can have asynchronous operations. Basically, you can do some things under the hood. You can just say that, okay, get this data. And when that getting the data is completed, then you can handle it. So basically what is happening is you're going to say that, okay, get this data from the server or read this file. And then while that is happening, you can continue your operations. And when you get the data, now as soon as you get the data, there should be something telling you that now data is available. Now you can handle this, you can do something with it. So there are provisions for that. One of the earliest ways to handle this was callbacks, and we'll get started with callbacks. We'll understand how that works, what are the pros and cons of callbacks, and then we will see what are the new ways that have come up to handle these asynchronous operations. This is going to be super amazing, very, very interesting. This is what you're actually going to use in real projects. So it is the thing, you just cannot leave the video right now. You have to watch this section. Let's get started. To understand callbacks, I'm going to write a function and I'm going to call it fetch data. Basically, what do I want to simulate? I want to show you that this data might take some time to be fetched from a server or something, right? So for that, I am going to use something which is used a lot in JavaScript. You will see a lot of people using this, set timeout. So basically, you can see that there is one handler and then there is number. So basically, you can put in milliseconds that after these many milliseconds, call this function. Now you could just actually pass the function like how we have been doing so far, or I can write the function over here itself. We just learned this arrow function, right? And the second argument is going to be how many milliseconds later. So if I put say 3000, that is actually 3 seconds later, or I can put 5000, which is 5 seconds later. So after this 5 second, this particular whatever I write inside this is going to be executed. So I'm just going to log something over here that this data is fetched, or fetched data. I'm going to write it over here. Okay. So after 5 seconds, this is going to happen. Now what I want to do using callback is basically whenever this happens, whenever this is successful, I want to call another function. I want to handle this fetched data. So callback is actually nothing but a function that is passed to be called when some operation happens. So in very simple terms, if you want something to happen asynchronously, you're getting the data. Once you get the data, once you receive the data, you want to handle it. That function being passed that handle this data is nothing but a callback. Very simple. So in this, I can actually call back this. And in this, suppose there are some parameters, I will show you how that works. Suppose I can pass this data. So instead of logging it, let's actually assign this to data so that I can actually pass it. So let data equal to this. And I can pass the data, or if some error occurs, I can actually pass the error also. For now, let's say that the error is null. So I'll show you that how you can handle both the situations, that some error is there, some error is not there. So now I need to write this callback function. So how will this be called? Let's see this first. So there will be one fetch data function. Now I'm calling this fetch data, and inside this I want to pass another function. Now I can suppose call that handle data. What is this handle data? This is going to be yet another function, right? So it's a callback function that I'm going to call whenever this operation is complete. Now here you can see there were two parameters, right? So here also I'm passing this data and error. And I'm going to write very simple things. So basically, if there is error, till now we have been doing console.log, console.log. Let's also see how to throw an error. So you can actually do console.error. It is actually going to give you error over there. And you can also pass the error whatever was passed, or else you can just log whatever data you got. Let's try running this. I save it and I refresh it. 1, 2, 3, 4, 5. Okay, my counting was very fast, but fetched data. You can see, right? So after 5 seconds, this is happening. And now let's see something very interesting. Okay, so what I'm going to do is I'm going to put a breakpoint inside this handle data. Okay, and let's see what happens. So initially, suppose I am doing a console.log over here, and I put start. Okay, and I save this. I am putting a breakpoint over here, and I'm running it again. Okay, so in console.log start, you can see that there is global, there is nothing else, right? Now what I'm going to do is I'm going to let it run from here. Now it is running 1, 2, 3, 4, 5. And after 5 seconds, you can see that in this local something came. Data, error, and this window. Correct? This came after 5 seconds. Why? Because the callback function was called after 5 seconds. So now this local is created, and you can see that data is fetch data and error is null. So now you can just simply run it. Right? This is amazing, right? So initially there was nothing in the scope. Magically there is something coming in the scope after 5 seconds. So for those 5 seconds, where is it? Where is it being stored? Now that is something interesting to talk about, right? So we'll talk about this, that for those 5 seconds, where is your data going? Because it could even take 100 seconds. Where is it stored? Because you didn't see anything in the scope. Also, just to show you how error can be handled, for example, suppose I pass over here server error. Okay. Now when I try running it, let's see what happens. So start got logged in the starting itself. Then we are going to wait for 5 seconds. And after 5 seconds, you can see that there was an error thrown, right? So there was an error thrown and I handled it. Okay, so what is callback? Callback is nothing but a function that is passed as an argument to another function. It is called when, not immediately, it is called after some operation has successfully completed. Like for example, over here, when this timeout has occurred after 5 seconds, right? So it is just a function that is passed as an argument to be called after some operation has finished. Okay. Now let's think about it. How would it be running? Now there are some terms related to it. This is just for you to know, good to know information. So basically what happens is that there can be a lot of callbacks that are registered, a lot of things that are happening asynchronously, right? Maybe you're getting data from 10 different servers. So there are suppose 10 different callbacks that have been registered. So you're waiting for 10 different data at different times. So now you need to wait that all these operations are running right now, and as these operations are completed, you need to handle them or you need to call the callback function. So because there can be many operations that can be running, so event queue and event loop is there in your JavaScript environment. What happens is that whenever you register a callback, the operation is put into the event queue. Now as soon as this operation is finished, your event loop is going to keep checking that is this task finished, is it finished? And as soon as it is finished, it is going to take it from the event queue and put it to call stack, to your scope, then it is called. Correct? And now if you think about it, one very, very interesting point, okay? So here you put the timeout at, okay, after 5 seconds, call this. Now just think about it logically. What might happen is that maybe you have put timeout for 10 different requests or 10 different operations, okay? So maybe you're handling those operations as well. So now there's a big event queue. Although what might happen is that these 5 seconds are now completed and now this callback function should be called, because there are things in the queue that are yet to be processed and event loop is going to pick them one by one. It is possible that your callback, your this handle data is not called exactly 5 seconds later. It will be called at least 5 seconds later, but it can be called 6 seconds later, 7 seconds later, 8 seconds later. And a lot of people get very confused at why is it happening? I've put the timeout for 5 seconds. Why is it running after 7 seconds or 8 seconds? So now this should be completely clear to you. Why? Because there's a queue of things that are happening. Maybe there are a lot of things that are happening, and what event loop is picking up is first something else, and your maybe this callback is picked up later. So at least for 5 seconds it will wait, right? It is in the queue right now. It will be ready to be processed by the event loop when the operation is completed, when the 5 seconds are completed. But it might happen that even though the operation is completed, it is still waiting in the queue. That loop will pick me up and will handle me or will call the callback function. So that is why getting your basics clear is very, very important. As you can see, I have written a very interesting code over here. So I've written a bunch of async operations that I need to do. And how I've written is basically there are a lot of deeply nested async operations that are happening. So you can see basically this one async operation, and there is a callback function inside this, then there's a callback function inside this. Okay, so once this happens, call this, once this happens, call this, once this happens, call this, right? And this is a very common use case, right? Like for example, in Swiggy, Zomato, like for example, has the payment completed? Oh, the payment has completed. Now maybe send the notification to restaurant or delivery partner. Oh, they have accepted it. Maybe send the notification to the user, something like that. This happens, then this, then this, then this. Similarly for Uber, Amazon, you can think a lot of cases, right? When this happens, do this. When this happens, do this. When this happens, do this. Now you see, this is basically looking like a pyramid, right? So with callback, the problems are, firstly, this looks like a pyramid and you feel like you're basically stuck in hell. So this is called callback hell, or the pyramid of doom. What is the problem? The problem is that there is basically deeply nesting. There are a lot of async operations that need to be done. After this, do this, after this, do this. So this is called callback hell or pyramid of doom. And as you can see, there are a lot of problems with this code, right? This is not maintainable. Error handling is going to be a nightmare over here. This is not readable also. I mean, it is very hard to make anyone understand, right, at what exactly is happening over here. So in order to solve all of these problems, so callback was for what? To handle async operations. Now, I told you the problem with that. Callback hell, pyramid doom. This is not maintainable, this is not readable, error handling is hard. So in order to handle all of this, came in promises. So now we'll understand promises, but it is very important for you to understand that why are all of these needed, right? So you know that we need async operations, so callbacks were introduced. Then we saw a lot of problems with callbacks, so promises were introduced. If you think about it, there's one more problem with this code. Basically, what you're doing is you're giving the control of calling your callback or calling your next function to another function. So it is not in your control anymore. So this problem is also called inversion of control. After talking about hell and a pyramid of doom, we need an elegant way, a readable way of handling asynchronous operations. Just think about it. What if there was a way to somehow, represent the state of this operation? That is it going to complete? Is it pending? Is it fulfilled? What is the state? Now, how would we be able to represent a state? Like, how could we represent it? Using an object? Correct? Now, that object that is used to represent that, okay, this asynchronous operation, is it completed, is it fulfilled, is it pending, is called promise. Promise is nothing but the object that is representing the state. Note that this object is representing what? It is representing an eventual completion of failure, that it is going to happen. Okay, so it has three states. What are the three states? First is the initial state, which is the pending state. So operation is pending now. It has not finished or failed, nothing. It is just initiated, pending. Next is obviously fulfilled, that okay, operation was successful. Third is obviously rejected. So these are the three states of the promise. Promise is nothing but an object. Let's try looking at the code. Let's try writing a promise. So basically what I need to do is I need to get some data again. So I'm writing a function for that, get data. Now what this is going to return me is a promise, is an object. And I will be able to handle it very beautifully. How? So basically when you have a promise with you, what you can do is call this get data, and from this, so basically from this what you would have gotten from this function, you will get a promise. Now on that promise you can just do then, and in this you would have gotten a result, and you can just handle this in a function. And similarly if you want to handle error as well, you can just do dot catch and you will have an error over here. You can handle it very easily. You can just add a function over here. So here what I can do is I can basically log the result and I can basically throw the error. Essentially what we are doing over here is we are passing two handlers, that if there is result, this is your handler, this is what you can do. If there's an error, this is what you can do. And as you can see, this is very easy to write. This is very readable. You can also keep chaining this. Like you got the data, then do this. You can put another dot then, and you can do, okay, sequential asynchronous operations. Basically, oh, the order was placed. Okay, was the payment successful? Dot, then place this order, dot, then send the notification, dot, then do this, dot, then do this. So you can have sequential asynchronous operations one by one, that when this finish, do this. When this finish, then do this, then do this, then do this. So you can have a chain over here. So that is why this is very readable, very easy, right? So what I told you now was that if you have a promise, how can you handle that? Basically using then and catch. But how do we create a promise? So this function should be returning a promise, right? It should be returning the object. Promises are the object that are representing, okay? So return what? Return new promise. And here if I say, you will be able to see over here. So there are basically two executed that you can see. There is one resolve, there is one reject, and then there is the function. So basically you will have to pass some parameters, and within this function you are going to do what? You're going to call your asynchronous operation. So in our case we are going to again do this set timeout again over here. So there are some things, and I can write a function over here, and I am putting a 5000 millisecond, basically a 5-second timeout. And I am going to do what? I can now do two things. I can either resolve this or I can reject this. So when we were in promise, you can see there is basically one resolve and there is one reject, right? You can actually see this. So these are again two handlers. Yes, basically this is also callback only. So we have basically resolve over here and we have reject. It will become clear, don't worry. So these are two handlers that when this operation happens, what can we do? Basically I can do resolve, and it is going to suppose say data fetched. This is basically going to go to my result. That is it in very simple terms. Let's try running it and see. So I'm saving it now and I'm refreshing it. So 1, 2, 3, 4, 5 data fetched, right? So what exactly is happening? Now let me show you something very interesting. Suppose instead of resolve, I call reject. Okay. So I've saved it. 1, 2, 3, 4, 5. Data fetched, there was an error. So I said data fetched only reject. Suppose there was server error. Okay. And now again 5 seconds you will see it. So basically what is happening is that when you say then result, so you can see the resolve one is called. When you say dot catch, the reject one is called. In very simple terms, so you can see server error. So if I just go back to resolve and I pass over here that data fetched, and suppose I want to add breakpoint in this then and catch. So when is it actually called? Okay, so if I put a breakpoint over here, let's try running it and see. So 1, 2, 3, 4, 5. There was nothing in the scope. Now there is basically this in the scope. there is data fetched in the scope. So basically this is also callback only, but now it is very, very beautiful. You can just keep adding dot, then dot, then dot, then, and you can handle it very easily. It is maintainable, it is readable. Error handling is easy because there is dot catch as well, right? So here you can see you are over here right now. Cool. Okay, quick revision. What problem were we trying to solve? The problem of asynchronous operations. Now, maybe there are a lot of sequential asynchronous operations that are dependent, like, okay, once this finishes, then this finishes, then this finishes. So we talked that, okay, callback is going to lead to callback hell or pyramid of doom. So then we talked about promises, which is basically an object representing the state that, okay, is it completed? Is it fulfilled? Is it rejected? Is it pending? Like that. So this is there. But, you know, the way this is written, dot then, dot catch, still this is not giving us the fields. I mean, I think we can still improve this. So in order to basically make it look like this is sort of an synchronous operation only, basically to get more feel that, okay, this is normal JavaScript code, there was something else introduced. Now, this is a topic that sounds very, very complex, but if you think about it, it is very simple. Still, it is going to use promises only. Still, this is going to be same, but just it's a better way of writing this code. Just that instead of dot then dot catch, is there a better way of writing this code? So for that, what we are going to do is we are going to write an async function. Now I can call this anything. I can basically call this, suppose, get data. I know this is not the ideal name, but just putting it get data for now. And inside this, what I'm going to do is add a try catch block. Now you must have heard about this a lot. Now inside this try, what I'm going to do is basically I'm going to have a result. And this is nothing but await. Okay, this was also get data. So I'm probably going to call this fetch data. I know right now it doesn't make sense, but okay, just bear with the names. So in this, basically I am awaiting this promise. So let's look at what did I do quickly. So I wrote another function and I just added another keyword async. Inside the try catch, in try what I'm doing is I'm awaiting this promise. So still it is going to return the promise, but I'm waiting for it to get either resolved or rejected, basically, you know, to complete its state. And once it is done, I will wait. Once it is done, I will have my result. And once that happens, I can actually log my result. And similarly, if error happens, it is going to be caught in this catch block. So I can actually do console.error and error. Now you must be thinking that from where did we get this error? This result we are getting from here. So yes, you get the error inside this catch. So this is how you get the error and you can just log it. So instead of this dot then dot catch, I am basically going to call this async function now. So I'm going to call this fetch data and let's see what happens. So okay, I'm going to remove this breakpoints and I'm going to try running this now and let's see what happens. 1, 2, 3, 4, 5. You can see data fetched, right? So this is exactly the same thing, just different way of writing code. You must have seen a lot of people using async await. Very basic thing, just in front of function add async, add a try catch block, await the promise. You can still see promises being used. Just it's a better way of writing code. Instead of dot then dot catch, you are adding a try catch block. That's it. So whenever you have to revise, think of it like, okay, we wanted async operations, then we came up with callback. What were the problems with callback? Then we came up with promises. Then could we improve the dot then dot catch? So that we did using async await. Congratulations, folks. I cannot tell you how proud I am of you. You should really give yourself a good pat on the back. You have understood really complex topics, which a lot of experienced folks also struggle with. So very good job. I hope you are also trying writing the code yourself and trying everything yourself as well. Please do subscribe. You have no idea how much it will mean to me. Please check out the hands-on high-level system design course that is starting. I have a bunch of live courses. And if you have stayed till here, I am guessing you really like my teaching style. So please do check it out. And if you like it, please enroll. I would love to have you. Now coming back to this, so we have done the major concepts that I wanted to cover. But in a lot of cases, what happens is that you're given an array and you're supposed to manipulate it. You're supposed to play with it. So there are a few higher order functions which are very, very common. And I wanted to talk about them. So there are 3 functions which are used to manipulate, filter, aggregate the data in the arrays. So we'll quickly look at them. It's very easy. You will completely understand, but it's very commonly used, so I thought I should definitely cover in this video, and it's the last topic of the video, so don't miss out. This is not the time to give up. The first higher order function that we are going to talk about is map. So basically we are given an array over here, a simple 1, 2, 3, 4, 5 array. I have also logged it for you to be able to see. Now what I want to do is transform this array somehow. Basically I could want to double it, multiply it with any value, triple it, multiply by 10, divide by something, convert into binary, convert into a hexadecimal. There are a lot of things that I can do. Basically I want to transform each of these elements in the array. So what I'm going to do is I'm going to do nums.map. Higher order function means what? We are going to pass another function to it. So I'm going to use the arrow over here so it will be clear. Now you should be able to understand. So firstly, what I'm going to do is pass each element in this nums. Okay, so suppose that element I'm calling it num. Okay, so I could call it x, I could call it anything. I'm calling each element as num. That is what I am passing in the function. And from there I'm going to return something. Okay, so when we are returning just one simple expression, so I can write like this also, I could have written like this also. So suppose I want to double and return, so I'm just going to do 2 into num, and that's it. So when you map it, what do you think you're going to get in return? So basically each element in this array I am transforming, right? So again I should get another array itself, but a transformed array. So suppose I am going to call it doubled nums. Okay, now this is going to be stored in this nums.map, and I can actually log it. So as you can see, this was doubled. So very simple, just in map, pass each element, and this is the expression. It is going to return the transformed array. Second higher order function that we are going to talk about is filter. It's very similar to map. The only thing is that instead of map, obviously we are filtering. Now filtering, as the name suggests, that we want some elements from this array, not all of them. So suppose, for example, I want just the evens or just the odds. I could have done that, right? So now my expression will change like what? Basically, if num mod 2 is equal to 0, then it is even. So this is the expression. And as you can see from this, only 2 and 4 are basically even. And that is why they were logged. In very simple terms, this is just filtering out some elements from this array. So filter is the term. It is, this num is representing each element in this array. This is the expression by which it is filtering out. And what is it returning? Again, an array itself. The third higher function, which is very common, is reduce. So here we are trying to reduce this array to a single value. Instead of in filtering, we were just putting some values from the array, right? In reducing, we want to reduce it to one value. Like it could be product of all the elements or sum of all the elements. Sum is a very common example that everyone takes. So we'll take the same example, sum, and then we want to reduce it. Now the thing is, we want to store the sum in some place, right? So along with num, which is basically the current value that I'm dealing with, I will also need one accumulator, basically the place where I'm actually going to store the sum, right? And my expression is going to be something like this. So I want the values to be added in the accumulator. So basically whichever num I come across, that should be added to the accumulator. And I want to tell from where I want to start the accumulation. Suppose I want to start from 0, obviously, right? When product, I would want to start from 1, correct? So I can do like this, and I'm going to log the sum. And here you can see that the sum is returned as 15. Now suppose I wanted product. All I had to do was basically accumulator into num, and here you can see that sum is not defined. Okay, so this is product. So if I give 0 itself, I will obviously get 0 because it is multiplying by 0. So I need to pass 1. So here you can see that the product was there 120, which is 5 factorial. So yes, we are done with the most common higher order functions. And that's it, guys. We are finally done with understanding the basics of JavaScript. Now there are a few more things, like we can do object-oriented programming also using JavaScript. So you can actually write classes, how to deal with classes, how to write constructor functions, factory functions, and all of this. So I can create an entire video on object-oriented programming using JavaScript. Let me know if you would be interested. If you have watched till here, that means my entire effort is worth it. But I would love it if you would try writing the code yourself. And if you have any doubts, let me know. I'm here to help you out. Let me know in the comments how you found the video, if you have any doubts at all. I would love to have you as part of my live classes and edu courses. But if not that, if you don't want to enroll for paid courses, it's fine. I'm still over here putting in so much content for free as well. If you think I deserve that subscribe and like, please do that. Please do share it with your friends. You have no idea how much it will mean to me. I've really put in a lot of effort. Thank you so much. See you next time.